Right, so if n is a non-square number and I write it as root n, then this is known as a surd. And a surd is an irrational number, meaning that it cannot be written in the form a over b, where a and b are integers. Examples of some surds are like root 2, 5 root 3, root 21. Because surds are irrational numbers, if you were to type it into a calculator, you'll get a never-ending number. There are some rules in which we can manipulate surds. So this first one here, root a times b. This can be split up into root a times root b. This is a useful characteristic because it allows us to simplify surds and manipulate surds. The second rule is root a over b. This can also be split up into root a over root b. So let's take a look at some examples. So if we have root 12, what you want to identify when trying to simplify this is find two products of 12. And one of these products has to be a square number. So 12 I can say is 12 times 1, 6 times 2, or 4 times 3. I'll choose the 4 times 3 because 4 is the only square number out of these solutions. So I can rewrite root 12 as root 4 times root 3 using the first rule. Root 4 is 2, so I can rewrite this as 2 root 3. This is a way of simplifying surds. And if you were to put this in a calculator, then you get the answer 2 root 3. Let's try another one. So let's say root 20 plus root 80. Let's deal with each individual surd first. So root 20, I can rewrite it as root 4 times 5. And that's going to be simplified to 2 root 5. The root 80 I can rewrite as root 16 times 5, so it's 4 root 5. So we get 2 root 5 plus 4 root 5, which is going to be equal to 6 root 5. If we were to look at this one here, we're to simplify it, they need to have the same root. So 3 root 80, root 80, remember, we can rewrite as root 5 times 16, so that's going to be 4 root 5. There's a 3 in front, so it's going to be 3 times 4 is 12 root 5. The second term minus 2 root 20. Root 20, I can rewrite it as 2 root 5 times the 2, so it's going to be minus 4 root 5. And the final one, 5 root 45. 45, I can rewrite it as 9 times 5, so 3 root 5 times the 5 is 15. So we get 12 root 5 minus 4 root 5 plus 15 root 5, which will give us 11 root 5. And the final one is we need to be able to expand brackets including surds. So if you have this example here, it's the same thing, just make sure you multiply each term. So root 5 times 3 will give us 3 root 5. Root 5 times minus root 3, this is the opposite or in the reverse of the first rule. That's going to give us minus root 15. So surds, as I said, are irrational numbers. Make sure you go ahead and you're able to simplify surds and manipulate surds using these rules we've learned.